When adding or subtracting fractions, we need to find a common denominator to find the sum or the difference. So recall, that does not apply during multiplication division of fractions, but only for addition and subtraction of fractions do we need to find a common denominator. And we need to do that not only in numerical situations, but also in the case of variables and variable expressions. Students sometimes forget that, but remember it applies to addition and subtraction. For example, 1/3 plus 1/5, I need to find a common denominator. And one common denominator I can always find between two fractions is the product of the two denominators. In this case, 3 times 5 or 15. And the way I might do that is I would multiply by 1 for each term. But in this case, that 1 will be 5 over 5 multiplied by 1/3, and 3 over 3 multiplied by 1/5. Essentially becomes 5 times 1, 5 fifteenths, plus 3 times 1, 3 fifteenths, summation of which is simply 8 fifteenths. And in a general form of 1 over a plus 1 over b, we can see that always works out to the product of the two denominators, ab, and the other denominator multiplied by the numerator of the first, that is b, plus the other denominator multiplied by the numerator of the second, in this case it's just 1, a. And that's an interesting format because it always allows us to quickly solve 1 over something plus 1 over something. You simply add up the denominators and divide by the product of the denominators. So what procedure can we follow in general? If we had three different fractions of form a over x, b over y, c over z, we again would take the product of all the denominators, x times y times z in this case, and for the a term to adjust that fraction, we would multiply by the other two denominators. So it becomes a times y times z plus b, then multiplied by the other denominators for b, in this case that's x and z, plus c times, the pattern is you multiply the other denominators, in this case x and y, and that will be the form of your final fraction summation. So recapping, it's the product of all the denominators, and then it's the summation of each numerator multiplied by the other denominators for your new numerator. So let's see that in practice on an example. In this case, my common denominator is going to be 5 times 7 times 3. That's 35 times 3, or 105. And each numerator is going to be 2 times the other denominator shown, which will be 7 and 3. So that's 2 times 7 times 3, plus 4 times 5 times 3, plus negative 2 in this case, times the other denominators, which are 5 and 7. And that will essentially be our result. 2 times 21 is 42, plus 4 times 5 times 3 is 60, minus 2 times 5 times 7 is minus 70 over 105. And that effectively works out to 42 minus 10, or 32 over 105. And that's how you'd find the common denominator for more than two fractions, added and subtracted. Let's take a quick look at another. In this case, my common denominator will be 8 times 6 times 4. Again, the product of all three denominators. And you could find a lower common denominator in this case, but in any case, the product of the denominators will be a common denominator. So then I want to take 1, my first numerator, and multiply by all the other denominators other than the denominator of its own fraction. So in this case, that's 1 times 6 times 4. And I'll move on to my next numerator, which is minus 5. Be careful about the sign, times 8 times 4. And lastly, my plus 3 times the other denominators, 6 and 8. And now we simply do a summation of the numerator, which will be 24 minus 160 plus 144, all divided by 192. And that in turn equals 24 minus 16 over 192, which equals 8 over 192, or 4 over 96. And that in turn can be reduced to 1/24. And that's my solution to my fraction summation with common denominators.